what are numpy, what is numpy, what exactly this is, right? So this is a very special Python package that stands for numerical Python, as I have written over there, right? It is a code library for scientific computing. In the advanced structure of this NumPy, we have SciPy. Okay, so this is a code library for scientific computing which contains a powerful n-dimensional array objects. You know about the dimensions? We say one dimension, two dimension, three dimensions, right? Like we have the you can say the graphs. When we have a plane graph, we say it as one dimension. We have two axes, x and y, we say two dimensions. When we have x, y, z, we say three dimensions, right? So there can be n dimensions similarly. So the very first question arises: what is numpy? I'll say numpy is a Python package stands for the numerical Python and is the code library for scientific computing. Okay, and with n dimensional array objects. Right, now this is numpy. Now the second thing comes, like, where is this numpy used, and then why we use this numpy. We'll go on everything, right? Why we use, where is this used? So Python numpy arrays provide tools, first of all, right? It provides you the tools for C, C++, etc. And like it can be used in the sectors for linear algebra. It can be used for random number capability. It can be used for uh, going up with like arrays and all, right? So it's mostly used in, as I said, like it is one of the feature of the scientific computing. So basically used in the mathematics sections and like going with calculation parts, right? Okay, so that is numpy we have defined right up there, right? Now what is a numpy array? What is that? So basically we sometimes say this numpy as np, basically every time, most of the times. So this numpy array is a powerful n-dimensional array object which contains, or which is in the form of a row or a column, and that can be like having multiple dimensions. Say as powerful n-dimensional array object in the form of some rows and columns. Someone came, yes, okay, like that. Now coming with the very first thing is d type, that is called as data type. Now every item in a numpy array, and more one important thing is a numpy array, sorry, numpy n-dimensional array is sometimes called as nd array, and not sometimes, mostly we call it as nd array. That is important to know, right? It is numpy n-dimensional array will be called as an nd array. So if it is like one dimension, then 1D array, two dimension, 2D array, and like that, right? So a D type comes here in the numpy, like we have in the Python, we have data types, and all for checking the types over there. We have something like D type here, right? So every item in an ND array takes the same size, a block of memory, right? That is called as a data type or D type. The space what is like the type of that uh, memory, you can say up like the size of that all. Okay, we say that. So data type here is that integer and float, and that integer float complex has a various other data types over here, various main domains over here, right? So how we install this package, like for those like doing everything in Anaconda, that comes like in the pre-installed over there, and like if someone is using other apart from Anaconda, they have to like install is using pip install numpy, like that in your command line, then you can go with that. Here we have to only write import numpy as np, that's it. Why this as? This as is like used to make something like if we are importing a very big module name, or like something like which is not easy to write every time, we use something a short over there. So here we are using np, that's it, done, right? So what is an np dot array? This is a function np dot array, right? So when we are talking about the dimensions, let's see what exactly a dimension means, right? So first we'll have a look on single dimension array, SD. Okay. Now let's say this is an A, and I'm saying this is an np dot array. Now this is for like this is a function, so I'll have to make a parenthesis, right? And inside this function, now you'll have to write your basically you can say you have to write a tuple or a list. Understand like that, right? The basic thing. You can write a tuple or you can write a list. I like both will work at the same thing, right? But I prefer to go with the list. First, we'll look on the array first of all, right? First, let's look on the array. Then we'll look on single dimension and all. So this is the array 1, 2, 3, right? This is one of the array. Now, let's take another array. What if I take two brackets there? So inside one list, there are two different lists. Now this will something else. Inside one particular list, we have 1, 2, 3, and also we have 4, 5, and 6. So two lists inside inscribed in one list. That can be called as a multi-dimension list, right? Now this is the kind of an array. Now before coming to this number of dimensions, right? Before coming to the single or multi-dimension, let's see the very first like important thing, that to check the number of dimension of any array, we use the function endim. Okay, endim function we use to check the number of the dimensions for any of the array. Now let's say if this is a single dimension array, if we are talking about a single dimension array, then let's say if, okay, A we have one array, but still we make it something. So how an A looks like we have seen there, right? Here. But still I'll print A and then A dot endim. That means first we are going to print np dot array, and like first we are going to print the array, that is 1 2 3, and then A dot endim means A dot the number of dimensions, that array dot the number of dimensions, and we are getting it as 1. Or you can even say number of dimensions equals 1, right? Now for multi-dimension array, more than one dimension means multi-dimensions, right? Oh, why to take print? So you can take dimensions equals person D, or that depends on you, like what do you want. Persons, we can write B dot endim. The values to be there, and we get dimensions equals 3. Now what the specific thing you have got here, like what is the common thing, or what is like one thing with which you can identify the number of dimensions? I can see like the number of brackets, or the number of the list openers we have is the number of dimensions we are having. Here, how many list brackets you have? The starting list brackets, list openers, we have 1. So 1 dimension. Here, how many list openers are there? 1, 2, and 3. Let's zoom it there. 1, 2, 3. Don't go with all other things, right? Only go with the list openers, how you can see like from the beginning. 1, 2, 3 list. So 3 dimensions, very easy, right? So you can use this ending function to get any of the values accordingly. Okay. Now the next. Now to set the number of dimensions for any array, we'll use the function of endimin. Endimin will be used to set the minimum number of dimensions for any array. Now let's say the C is going to be an array. We have an array, right? How many dimensions we have? Anyone can tell? Quick.
2.
Great. So we have 2 dimensions, right? I'm taking the same thing right now, pasting it again. But this time, I'll say this C, here give a comma, and then endimin to be, let's say, 3. That means I want at least 3 dimensions for this C, and then I'll print this C and also the C dot endim. Let's see the answers respectively. Yeah, so we got the answers, right? What you can see here is 1 2 3 4 1 bracket, 5 6 7 8 1 bracket, inside there one more bracket, so there is 2 dimension, right? Here I can see 1 2 3 4 5 6 7 8 inside one bracket, and then this whole inscribed in another bracket, and that's what we are seeing, the 3. So like finally if we see on the C, we have something there as the 3 brackets, right? But we did with the 2 brackets. So that like if you want to set up the things, you can, like if you want to set up the dimensions, you should remember endimin. right? So that's the basic difference between ND min and ND min, right? ND min, ND min. That's the two important things. Now, I discussed something regarding the data types, right? So what exactly are those things? Okay, data types. So like if you want to set data type of any particular array, we just use D type to set it there, right? So what are the D types in the numpy we have? We could have like say any number and get the points. How? Let's say D is equals. We have some array, yeah. So A dot D type integer 64. We have integer 32. We have integer 16. We have integer 8. We have integer 4, no, 8, 16, 32, 64, 128, and something like that. Like float, we also have something like same from 16, 16, 32, 64, 32, yeah, 8 times 8, 16, 32, 64, 128, and something like that, right? So complex also with the same 256 even, right? Yeah. Alright, so these are the data types you can look onto. Like if you are making an array and you want your data type to be something different, you can say your d type to be, like if you want float, you can say, so you have to write np dot float anything 32 or something, like if you want whatever you want. See, it will be a float of 32 bits. If you want something in the boolean, you can like do in the boolean. Complex you want, you can make it complex. Okay, fine. So accordingly you'll be getting the values, like you can use d type to get the respective datas. So you have boolean, you have integer, you have float, you have complex, right? So what exactly this is 32-bit and all? Let's go with that. So this plays a very major role in recognizing the parameters, like that is the size, the shape, what is that? What's that? Item size, yeah. Item size. This three major thing helps you to determine in this three functions particularly. How? We have seen that ND mean working, right? Defining the minimum number of dimensions to be there. Like if D is having a data type, if I look on to the D dot data type, this is float of 32 bits. What more you can do is the data type name, if you want to write d type dot name, similar, same thing you'll be getting up there. What happens most of the time, like if we write d dot d type, we get something data type is equals to float 32. If we write the name, okay, that is something error. Then only we get the name over there, right? That's the thing. Okay. Now, see, for any of the array, let's say if this is C, having 1, 2, 3, 4, 5, 6, 7, 8 items, right? So to see on that total number of elements present, what we can do is length of C giving you 1, right? But how many actual elements over there in the C? C dot size 8, right? While length is 1, if you look onto the C, what you'll find? What you'll find? If you see, this is something like, let me copy this, paste it here. See, what I can find here is, this is a complete list 1, this is a complete list 2nd, right? Something is missing. This is one of the list 5, 6, 7, 8. This is one of the list 1, 2, 3, 4. And this total is inscribed in one another list, and this all is inscribed in one other list, right? So if I say this of 0, obviously I'll be getting the second one, right? The 0 of this will be taking me to 1, 2, 3, and 4. And the 0 of like, if you go with the 1, you'll be getting 4, 5, 6, 5, 6, 7, and 8, right? So with this, you will be going to get 1 and like all with the indexing purpose and all. Okay. So this is inscribed within the three dimensions. So as you're getting the values respectively, right? So total size is 1, 2, 3, 4, 5, 6, 7, 8. But if I see the length will be only 1 because there is one element only inside that list. If it to see on the things, right? So length of this will be now S2, right? If I change things further, this become 4, right? And that will be multiplied by 2 to get the answer. That will be your answer, right? If you go with the minimal things like the basic functions and all like that. Otherwise, you'll be getting 1, right? But to see the size respectively, directly to see the size, not like, because this is confusing and many times you do mistakes over there. So don't go with these procedures. What you have to go is see the size, array name dot the size to get the total number of size, the total number of elements present inside that array, right? And for the name you will get to it. Now what is the fundamental behind this all 32, 64, 60 and all will we get to know, right? Okay, fine. Understood what is that particular D type means of. Now if you have C, you say print an array of C, okay, where the data type is equals to boolean. See, you'll be getting true, 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 and all, right? But if we have any value of C as the 0 for any value, in case if in the C, in any of the value if I have 0, I'll be getting one false answer, C, because 0 stands for false. Apart from 0, everything you take is like true also. Like in the boolean values or boolean languages, we say 1 to be true, 0 to be false, and apart from 1, apart from 0, everything which comes we take as a true, right? So that's the difference between the true and the false, like 1, 0, 3, F and all. Okay, cool. Now okay, so size has been clear, data type dot name has been clear. Now shape and item size will go on. Now if C is having 3 dimensions, having 4 answers like that, so we can go with the C dot shape, giving you a knowledge of the rows and the columns there. 2 rows with 4 columns and with one main domain, right? That is, inside one list you have 2 rows and 4 columns. Like you have 3 dimensions, so this is there as it is defined. Okay, x, y, and z. So z is 1, x is 2, and like you have 4 columns like that. So see, 2 columns, 1, 2, 3, this 1 and this 2, and 2 columns with the 4 rows. 2 rows with the 4 columns, 1, 2, 3, and 4. Like if I say E is equals to, I think we have B something. No, A is better. 1, 2, 3, 4, right? Now I'm going to look onto the shape. What would be the shape? Can you tell?
1, 2, 2.
1, 2, 2, no. 2 row and 2 column. Where is the 1 coming? See, you have one list, you have one list, all inscribed in 1, that's it. 1 row, 2 column. See here, in the C, you were having one list, all inscribed in one list, and this all then again inscribed in one list, so you are getting the same. Here only you have one list that inscribed in one list, 2 rows, 2 columns. See, 2 rows, 2 columns, that's it. It increase and go in the 3 axis, then you have the major changes in, like not major, minor changes in your spaces, right? Graphs, you can say. All right, that is shape. Now next. So what is the usage of this item size? So you have got the size. If I talk about b dot size, what is the size? Yes, what is the size?
4.
4 is the size. Now, what is the size of the individual element if I want to see that? Right? In the bytes, like storing up values over there. What is the size of the individual bytes? What you can do is you can write b dot the item size, that is 8. Now see, the total size is 4, right? Size means that total elements is 4, and the item size is going to be 8. That is, every element inside that 4, not every element, that is 4 elements is having a size of 8 bytes. So what will be the total, you can say, size in bytes for this array?
32.
Yeah, so individual can be given them, like, so how we are calculating the individual item size? What is the thing over there? How we are calculating this? Now this can be calculated as whatever the data type we are having divided by 8, like uh, this is b, right? You have integer of 64, right? You have this integer 64 over there. Let me do this one something. Hmm, yeah, that can be done. 64 after changing 70. Okay, fine. Yeah. So whatever the name comes, like if it is 64, that's okay. 64 will be divided by 8 to get the answers. That is 8. So obviously the data type would be, the item size would be 8 bytes. Okay. Remember, like we had something of d, is that the float? Yeah. So we have d with the float 32. Then what will be the data type of this d? Item size of this d?
32 divided by 5.
No, 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 not 5. Always by 8. Right? Always the data type would be divided by the 8 to get the desired sizes for this item size, right? So here also 32 divided by 8 to get the answer, that is 4. So if I check d dot item size, we'll be getting the answer as 4. Got it? That's the major difference between the things. Okay, I think that is clear again. Okay, so you can work with numpy 16, numpy 32, numpy 64, numpy 8, and like all these things. Okay, so most of the times like we have numpy 8, sorry, integer 8, 16, 32, 64, and this all can be represented by I1, I2, I4, and like that. No, like if I say an array, let's take something great. So here if I say the data type to be integer of 32 bits, have to define it as, will be defined over there, right? But in the same case, if I write Hmm, see, like for 8, 16, 32, I'm thinking that it will work for 8, 16, 32. If this is 32, it can be also 32. If I go with I4, that is also integer of 32. See, the short forms I'm talking about. So 8 could be written as I1, 16 as I2, 32 as I4, like that. Okay, right? So there can be the shortcuts for all this. Like instead of writing this all, you can just take I4, I2, I6, something like that, right? So that returns you the respective results accordingly. Now, when we talk about the shapes and all, like what we got there, the rows and the columns, right? The respective rows and the respective columns. So if we say array, what is the shape of this? Yes. What is the shape? Okay, fine. So you have basically 2 cross 3. That is 2 rows and 3 columns. If you look onto the edge, see 2 rows, 3 columns. But what if I want to make that as 3 rows and 2 columns? That is reshape something, right? So what I can do is, you can just write edge dot reshape and then write the shape what you want. Let's say you cannot do with any of the shapes, right? Because it is 2 cross 3, so I can only go with the multiples and all. So I can take it as 3 cross 2, 1 cross 6, 6 cross 1, giving results 1, 2, 3, 4, 5, 6. You can see the results changing up there. Okay, that's how it is being done, right? You can change any array accordingly. Now, So we have talked about like one dimension array. We have discussed about two dimension array, three dimension array, like n dimensions array. It can be anything. Similarly, do you have a question? Do you arise with a question that what is then the zero dimension? What is the number? What is that thing which is having no dimension? What is zero dimension then? If everything has got dimensions here, then what is a zero dimension? So zero dimension means, like, if you go with the bracket sense, when I what I said is zero dimensions means zero brackets, no list, right? So that is particularly the zero dimension thing. Zero dimension can be stated as print an array okay. So that is a zero dimension figure, right? I think that is clear to you, like, okay, fine. So that is how we go with the dimensions, the very basic thing. I think that is clear to you, right? Having any doubts in zero dimension, one dimension, two dimension, three dimension, any of the stuff we discussed till now, because that is important. Anyone having any dimension, sorry, any questions can ask. Oh, okay. So for now, like, we have completed our shapes, we have completed our data types and all, like, okay. So we have integer, float, complex, boolean, as I said over there, as our dimension types. Oh, numeric type, okay. Now reshaping has also been done over there. So the interesting fact about the reshape is, like, if you reshape some of the button, right? If you reshape some of the, like, you say uh, in dimension array, let it be 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. For any dimension of the array apart from one dimension, right? It breaks down the array to one dimension, irrespective of the number of dimensions of the array is having up. Like, it will be breaking down the array to a one dimension array. How? Let's say if this is a three dimension, or like whatever it is, three, 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 three. Where is three? After building, yeah, 1, 2, 3, three dimension, right? Okay, three dimension. So if I want to make it as a one dimension, what can I do is I can write a reshape of -1, giving me the respective results over there. No? So I can just write print see 1, 2, 3, 4, 5, 6, 7, 0, getting me as a result of a one dimension. Got it? Next. In like in class 12th, yeah, in class 12th, we have a chapter of matrix where we read about ones, zero, empty, I, right? Not I. We read about identity matrix, something called as. What is that identity matrix? Yes, anyone can say.
All the
Someone.
elements is
Yeah.
one. All the elements of the matrix is one.
Hmm. Okay. So for here identity matrix, we have something called as np dot I. So you, inside the parenthesis, you write the number of rows in the columns because this is something kind of square. So it's a 3. So it will be giving a 3 rows and 3 columns. And the diagonals will be having 1. Apart from that, everything will be 0. That is an I. And you can get to your data types and all. Yeah. See, for 5, you'll be getting 5 diagonals, and it's apart from everything, this is 0. Now, with the 0, we also read about something called as null matrix, 0 matrix, right? So, for that, we have something here called as zeros. Same case here also, like np dot 5 zeros. So, you'll be getting 5 zeros. Similar, if I say so 25 zeros, and then reshaping this to 5 cross 5 can make it 5 to 5 for 25. Untype has no attribute of reshape. Okay. Oops, we have done an error over there. So see, np dot zeros, reshape it to 5 plus 5 and getting the results accordingly. So you can even write the data type, one boolean, see all the results as false because everything is a null. So obviously the values will be a null matrix. Similar to this, like positive 1 will be an ones, right? And that would be a shape. What reshape of 5 would be giving results? Somewhere we have made a mistake. We 5 of ones. That's okay. Yeah, so that is ones. That is I. That is zeros. Right. Similar to this, we have empty. Right now, what is empty? Empty is, guys, like something which is an uninitialized value. Sorry, something which is having an uninitialized values. That is, you don't define all those values. That comes like a random values basically. If I say np m np dot empty, and I say it to be a 3 by 2, that is 3 rows 2 columns, not defining the data types. What can I see? 0 0 0 0 0, all the null matrix basically, right? Not every time, this is not every time done, right? Getting something? mm, np dot float, see, value changes respectively, right? So that is basically an uninitialized value. You don't define all those values, that comes like with a random thing. Okay, you never define these values because these are basically all in a random state, so therefore you get such values over there, right? Very similar to this, we have full. Now what is full? Obviously you will be giving one value, and that will be, we'll be discussing this, the last 3 4 functions what we did today again tomorrow. Like if I write np dot full 3 by 2 with 5, so I need a 3 cross 2 matrix with 5, everything will be filled with 5, and that is how we are writing up the things. So I feel that things would be clear. We'll be discussing these things again. Having any doubts for tomorrow's session, for today's session? Any doubts with any of the thing?
So in empty, sir, why did it take float values? And in full, why did it take integer values?
Can you speak a bit louder?
In empty, sir, why did it take float values?
It's not like compulsory for float. We can take for the integer, but the problem
No,
is
no,
like for the for the.
float.
Mhm.
That time it took float values, sir. Just remove this np dot in.
Okay, you need to remove this.
It, why is it float values here?
See,
Though it is not mentioned.
if I say 0.56, 0.34, right? If I get an integer of this all, values are same, getting value same, but is this
Yeah.
value same? 0.56, 0.34? No.
No.
Similar to this here, we are getting a round of float in empty, that is 0. But if I say that I want to get the exact float values, that what exactly it is being given over there with the data type, because I know that is not 0, something around it would be like nearest to something else, right? If I change the values, right, you can get it more understanding. Like see, we are having 4 rows 2 columns. Even if I increase of the things, removing the data type right now, you can get any values. Sorry, that is not a consistent one. Got it?
Yes, sir.
You'll never get like same value every time, right? Because you don't initialize any values, you are just giving a shape that you want some values within this 3 4 by 3, that's it. 4 rows and 3 columns, you want to get some values over there, and that's like being printed over there with anything. Okay, so like you say, you want some 3 cross 4 values. Oh, sorry, I'll get the values respectively. Increase 3 cross 5 values. So values will be given, and you don't make any changes over there. Right, that is how it runs. Okay, I hope that is clear to you. Any more doubts? If you have, you can ask up. If not, then okay. You can. So what you'll do today is, for whatever I'll be sharing this in your drive, right? So whatever you will be doing is, you'll be going in the help. Sorry, here in the numpy we don't go with the help. We write np.info for the help purpose. Okay, let me write np.info and then the function name. Like if you want to go with the empty, you can just write like this, run this, you'll get an empty documentation. What it returns, what are the parameters it can take, what it returns with the parameters. Or we can go with the ones, zeros, full, empty, like notes are there written up like what empty does. Some examples are there, and you can go with this all right. So today our work will be like to go through all the functions we did, right? That is, what is the endim, what is endimin, what is so concluding here like today's conclusion, summary topics, right? So what are the functions we did today? Endimin, first of all the number of dimensions, then the next is endimin, third one is size, shape, item size, data type, reshape, ones, zeros, empty, I, anything more?
Full.
Mm-hmm.
Full.
I think that's it. Minimum, maximum, reshapes, and I think that's it. Whatever we discussed today, something. Yeah, that's it. So 11 topics. All right. So go through all these functions with the infos. Okay.